Welcome back to today's video. Today we're going to be continuing with objects. So on day 3, which was yesterday, I finished on, I think it's level 8, which is dynamic keys. So today I'm going to continue with dynamic default properties, property key, read only modifier, sconst, and object.freeze, satisfies, and function overloads. I might go over and do tuples, but let me just see how many are there in tuples. Okay, like I might if I am fast. The problem is that the goal is to not be fast, but is to do everything and understand. That's why I might not go do tuples. So let me just get started and see where today goes, how far today goes. Dynamic default properties. So there's this seemingly weird but useful thing that you'll see in the wild type format. Okay, this is a field of type string, then the email. Okay, whatever that means. Okay, if what you're concerned about is which types are allowed in the object, you might wonder why email and passwords are even there. After all, you can specify any string key value pairs in this type, right? You use the syntax to require certain properties, in this case mail and password. The type above says the object must have an email and password property, and it can have any number of additional string properties. Oh, okay. Okay, I see. So like this type just says we should have like an email and password, but we can have any number of additional string key value pairs. Okay, we can have any number of additional string properties. Okay, here's another example. Okay, this will just say that we can have like a key of string, and the value can be any number of properties in which the value is a string, and then we can have like either a number string or boolean. Okay, this type says the object must have an email string, password string, and age number property, but it can have any number of additional string, number, or boolean properties. Yes. Okay, I see. I strongly advise against overusing this pattern. Only use dynamic keys when you truly need unknown keys. If you have optional keys, just use this operator, the question mark operator. Okay, okay, like this is good advice. Assignment: support needs to communicate whether or not someone is available, so they've added the do not disturb and out of office properties to mail references, which are here. Okay, but I'm going to introduce the bug. Run the code as is and see the error. Okay, so the function takes something of this type. Okay, boolean. Here like the keys are like always strings, so this here the keys, like I think they are always things like strings, and like even if it's a number it will be like just a one string, I think. I'm not sure. Okay, so don't touch the code below, so we're just gonna fix something up here. So it's a function preferences, mail preferences, returns a boolean. Preferences do not disturb. Or what does like double mean again? Does it mean or? I think. Okay, I think it does. It means or. Okay, but don't we? Okay, let's see. Its preferences false dark. This would return true because no. This will return to be false, or it will return false, but it will be it's like negated back to true. True, false. This will return true. Let's see. Yeah, this will return true. Yeah, and then it will be negative to false. Yeah. So what are we doing here? Don't touch the code below. Do not disturb us out of office. So like, are we just making it? Are we just making our code taking additional thingies? I think that's what they say. The code will have an error, so we'll see. Dynamic default properties. Okay, let's see. Just name it dynamic default prop. Yes. Yo, it's a very long name. It's a very long name. Dynamic default prop. This is reasonable. And then we'll just do this. Okay, and then just try to close everything and open this one only today. Okay, we just run and see type of error that will be returned. It's done. It didn't return anything. Okay, let's. Yeah, it didn't. Okay, it would get an error for when there is an additional like property in the object. Then like, you remember like in that lesson, like if the object has like one additional properties, it will just check if like it satisfies. No, it's not the same. It's not the same. But that additional property won't be used. So let's just see. Let me just pass in this object to our function and see if we get an error. So here we just console. What's the function name? Can concat. Then we're passing in an object. Okay, we'll have like an because because if we're passing it like this, then we'll get an error. But if we create an object like this, and pass it, I don't think we'll get an error, because the object will satisfy. It will satisfy. Let's see. Yeah, here we will not get an error because this object satisfies. It will have this thing, and they're the only things that are gonna be used. So it will quack like this. So we won't get an error. But if we just pass here, if we just pass it here like this, if we just pass it in here like this, then let's see. Then here we'll get an error for this last one. And I think I have said that because this object cannot be referenced. This object cannot be referenced anywhere else. Okay, so like it needs to match. This needs to match this. But okay, because they want to teach us dynamic dynamic object properties, dynamic default properties, then we can just go ahead and put this to remove this error. Okay, yeah, let's do this. Okay, no, we need to do this actually. Let's see. What? Okay, now those ones are crying. Okay, let me see. Why are those two crying? Like, why? Don't disturb after boolean is not assignable to the string. Okay, let's see. Wait, what am I supposed to do here? Must have an email property. Fix the preference type. In addition to the required property, it should allow any string to map. Okay, I see. So you would have fixed that. Okay, now the error will be gone, and these are dynamic default properties. Okay, it's just saying like you can take any string, which can take in an additional property which can be a string or a boolean. Okay, I see. Beautiful. Just go ahead and run the code. See what will be returned. It returned false. Did it return false to where we copied? It did return false. Okay, let's move on. Property key. With dynamic property keys, we've only used the string type so far, and most of the time that's all you need. However, JavaScript supports number and symbols as property keys. Okay, TypeScript actually has a built-in type called property key that presents all possible property key types. Okay, so property key will be just like a type like this. You can take in a string, number, and a symbol. Okay, you can't use an object as a property key. Okay, a symbol is a unique and immutable data type that can be used as an object property name. It's kind of like a string, but it's guaranteed to be unique. Okay, a symbol is a unique and immutable data type that may be used as an object property name. It's kind of like a string, but it's guaranteed to be unique. Okay, yeah, I think I've read about symbols somewhere. So instead of this, we'll just put property key here, and then we're saying it can be of anything. Okay, const change server infrastructure tags, and then we'll have name, which will be definitely required because JavaScript support numbers. Okay, I said JavaScript doesn't support numbers. I lied. Okay, yeah, it support numbers. Okay, boom. Then symbol, row, whatever. What did they do? Yeah. Okay, symbol. Okay, the symbol, the key will be row, and then the field will be admin, I guess. And then this is immutable. It's immutable that can be used, and it's just to be unique. Okay, assignment. New optional security features were added to the support AI preferences managements once all emails users to enable at least one security methods. Okay. Two-factor biometric. Okay, you have to do not disturb. Okay, you have to enable at least one security method. Whatever. If the preferences enable either two-factor authentication, return true. Otherwise return false. Okay, if preferences enable either two-factor or biometric lock, return true, otherwise return false. Okay, so copy that, and then you are talking about property keys. Okay, let's see. Okay, if okay, they're doing, I indent with 4, I don't indent with 2. Okay, so I have to if, let's do if preferences dot two-factor. What do we use? Okay, we just say two-factor. Okay, thank you. And then our preferences dot biometric lock. Okay, then we'll return true on this. If any is true, then it will be true. They can both be true. Okay. Okay, I think we've solved that. It's so simple. Wait, this was actually simple. Okay, if the object looks like this, let's look. Biometric is true. Okay, but it's true. Biometric is true. This is false. It will be true. Biometric is false. Then two-factor is true. This will be true. They're both false. It will be false. Okay, let's just copy anyone. Okay, so the object will pass here will be this. Let's just do that. Okay, this is what will pass to our method. This was relatively simple, man. What's happening? I feel like I'm getting too advanced for this course. And then we'll pass that object. Yeah, that's that. Maybe it's too big. You want to be able to see. Man, just make it big. Yeah, That's how we solve this, and this is supposed to return true. That's what's supposed to return true. Let's see. Okay, it works. Yeah, this was simple. Let's go. Let's move on. Read-only modifier. The read-only modifier is very similar to the const keyword in JavaScript. It's an added feature of TypeScript that lets us mark object properties as read-only, meaning they can't be changed after initialization. Okay, normal object properties are for the mutable, but if you use read-only, you can make your property immutable. Okay, yeah, this will be just read-only. You can only read, you can't rewrite or reassign, whatever. Now we can create new points like this. Okay, 10 stays fixed, and we can update y property just fine. There, if we try to update the x property, TypeScript will throw an error. Of course, read-only is pretty awesome. Just keep in mind that you probably want read-only properties less often than you want const variables, because recreating entire object and copying all the fields can become painful and verbose if you do it too often. Somebody intends to introduce a bug in our preferences logic. Fix it. Run code as is and see the error. Only do not disturb, and out of office should be read only. Okay. Yeah, this will not even code, so yeah, this won't be read only because they just say only do not disturb and out of office should be read only. So this one will not be read only. So the additional thing that will be passed will not be read only. So I will not even code this one. So the additional thing will be serial. This can be changed, whatever. Okay, let's just pass. We get the read only. It should be used less than const. Okay, as const and object.phrase. The as const assertion creates a read-only type using literal values. Okay, it creates a read-only type using literal values. Const color constants. Okay, it creates read-only type using literal values. The as const assertion creates a read-only type using literal values. Okay, error properties. Okay, does not exist on type read. Okay, so we can push into this const color array. It works great with objects too, and unlike most utility types and object.freeze, it automatically makes all native structures read only as well. Okay, it works with objects. Let's see, as const, so it makes all messages. Okay, so everything here will be read only, and we cannot push anything here. Okay, we cannot reassign anything, and we cannot push anything. Property push does not exist. Yeah, you can on type read only. You can't push. Okay, you can't. Not these things. The array here will be read only. It will be like a read only array. So you can only just read this using the indexes. So objects.freeze. The object.freeze method is a built-in JavaScript function that prevents modification to the top level of an object at runtime. Okay, this is at runtime. It makes the object immutable, but it does not affect the TypeScript's type system. Okay, prevents modification to the top level of an object at runtime. It makes at runtime. Okay, cannot assign. This is fine. Okay, this is also fine because the array is not frozen. What is frozen? Okay, to the top. Okay, what? Wait. Okay. Okay, so it will prevent modification to the top level of an object. So anything that's here, isn't the array top level too? But it does not affect TypeScript's type system. Okay, so apparently here the array is not. It won't do this. Also works fine because the array is not frozen. Okay, this is not read. This is not read only. This is freezing, man. Ish. So how do we freeze? We do object.freeze. It will freeze the top level stuff at runtime. Okay, this will not be freezed. Okay, we can't reassign an API URL, but we can do this. This is fine because necessary properties are not frozen automatically. Okay, this is also fine because the array is not frozen. Okay, TypeScript is smart enough to recognize that object.freeze is being called. So it gives us a nice compile time error when we try to modify the top level properties. And because the object.freeze is a runtime operation, it will still fail in runtime if a mutation actually happens. It's worth mentioning that in non-strict mode JS, mutations of frozen object are silently ignored, but in strict mode throws a type error. Okay, this is in JavaScript. Assignment subrealize default mail preferences. The ones each new user starts with should be logged. Preferences should be logged so they can't be mistakenly changed. Okay, so we just add object.freeze. What? Just do object.freeze and pass that object there. Just getting the syntax. So here we just write it here and passing the object inside the object that freeze. Sorry guys. Sorry for that. Just people's messages on my other phone making me problem. Okay, yeah, we get that. We get it. Okay, it's a runtime operation, so it will still throw an error at runtime if a mutation happens. Whatever. So in JavaScript, it will throw a type error if it's on use strict mode. If it's not, it will be ignored. Okay, that's JavaScript for you. Support AI default mail preferences should be locked. Default mail preferences should be locked. They can't be mistakenly changed. Here they'll be read only, so but they're locked. And the code is that it's not compile time immutable. Okay, this code apparently is not compile time immutable. Make it compile time immutable. So object.freeze is compile time, is runtimes. Whatever. Okay, take a look. What does it mean to this? What's the difference as const? This one makes them read only, means you cannot change them. This one freezes the top level. Take a look at the test. While the run test expect compile time immutability, the sub tests also expect runtime immutability. Make default preferences both compile time and runtime. Okay, so we can just pass can we pass object.freeze and still do as const? Make default preferences both compile time and runtime. Which one is compile time and which one is runtime? Okay, I'm thinking object.freeze is runtime and yeah, and the hello yeah, I'm not doing anything. 4617. Sorry about that. Okay, so like object.freeze is runtime and this is compile time. Okay, runtime happens when the code is running. Okay, compile time happens when the code is compiling. Let me just ask ChatGPT. What is the it's quite dark in here. Just switch on the light. difference between compile time and run time. Make example using sconst and object dot phrase. Try to get a clear understanding here. Quick question, let's break it down. Compile time versus runtime. Simple explanation. Compile time, when your code is analyzed. Let's pass again.
Why not zero again? Why not zero again?
Remember where we were. So what are we doing here? What are we doing here in VS Code? Okay, I don't think we were coding. Okay, so I was reading here compile time versus runtime using sconst and object.freeze as examples. So compile time is when your code's compile time is analyzed before your code runs, usually by the compiler, e.g. the TypeScript or Babel. Errors like type mismatches, syntax errors are caught. Okay, runtime, when your code is executed in the browser or Node.js, errors like undefined is not a function happens. Okay, with sconst, it will be sconst. We can't send. Okay, explanation. Sconst tells TypeScript at compile time this object is fully read-only. This prevents accidental mutation during development, but does not affect runtime behavior. The JavaScript output doesn't block mutation. It's just a developer tool. Okay, so this thing can. Okay, this is just to prevent you from mutating this, but it can still change sometimes later somehow, whatever. Example with this is a runtime, this is compile time. Yeah, as I said. Okay, passing the object, whatever, won't change, but no compile time error. Okay, explanation happens at runtime, meaning even in plain JavaScript, after running, the object becomes immutable. Silent failure. So, okay, this finishes compiling and then gets an error when this happens. This will not even compile. Am I right? Feature when compile time, runtime effect, type checking, actual runtime mutability, error type, compile time error, runtime silent fail or type error, language TypeScript only, JavaScript and TypeScript, mutation protection, Node.js runtime protection, actual runtime protection. Okay, yeah, so I was thinking, okay, so I guess I just need to try. Okay, this will, but the only difference is the errors they will throw. Or does it mean that this will compile, but this will not? Let's just do this. Okay, like it is showing error like this whole. It is a read-only property. Okay, let's just try and do as const say now everything is an error. Let's just do this. See what's popping. Okay. Oh, let's see. Okay, so this makes everything read only, but that one makes the top level phrases so you can change it. Whatever it means. Okay, let's move on or I make the video longer. The satisfies operator validates that a value matches a specific type without changing its inferred type. It solves a common pain point in TypeScript's type system before satisfies. You often had to choose between letting TypeScript infer types, good for flexibility, might miss errors, using explicit type annotation, good for catching errors, but loses literal information. Here's an example. If we have this yellow, let's see, satisfies. The satisfies operator validates that a value matches a specific type without changing its inferred type. Okay, it's of a common pain point in TypeScript type system. Okay, validates that a value matches a specific type. Okay, see, explicit, specific plain style typo alan. Yellow what? Okay, to get around this, we can create an okay, let's see. Classic lane, okay, using type inference, flexible but might miss errors. I don't understand. To get around this, we can create an explicit type and use that to catch typos. I see. Okay, using type inference. Oh, this will be inferred. Okay, this will be inferred. Yeah, you're just saying it is of this type. Okay, error yellow is not. Yeah, if you have a type. Okay, yeah, this won't have any problem. It will be inferred as like an object with like an additional, but yellow with one L, right? The trouble is that because our color map type uses a string for the values, we lose more our specific literal value type information. Rest is any string where it is used. The type of that would be string, right? Type is the type of colors the red, that be string, right? Let's see. Satisfies. Oh wait. Okay. Satisfies. Okay, here to do. What be the error here? This, and then we can add any number of additional warawara key property. Oh, okay. Satisfies to do satisfies. Okay. Wait. We keep the literal types. Oh. Okay. Oh, okay. I see. Okay, I see. Yeah, like when it's inferred, the type for red will be this string. Okay, but if we do like this, we will use the literal types. When it's inferred, this type of set colors, it will be there will be string. Okay, so what's the use of having like a literal type? Satisfies color will keep the literal types. Satisfy operator gives us the best of both worlds. The lead architect at support AI. Oh, that's me. Created the male preference type so that no one would accidentally create malformed malformed male preferences object. Someone did it anyway, but at least TypeScript caught it. And the code is let's see, let's fix the typos. So this was male preference. What would be the type? Yeah. Okay. me just copy it and just go to VS Code and try to fix the error. Yeah, this was saving errors. Delete it. We don't play around here. Okay, let's see what the error type. Do not disturb false signature. It's a string does not satisfy the expected. Okay. Okay, out of office, let's see. Yo, they're not equal still. Just copy this and then put it there. Let's see. Do not disturb. Make sure that we fix the error. Okay, yeah, these ones are fine because like they're not even there. They're just additional things that you can add. Okay, we get it. So you can't have typos. And then now the types, when you have this, the type is a string. Isn't it string literal duck? The type B? What? Oh, then see how about this. Yo. Okay, so yeah, we learned that. Function overloads. Okay, function overloading. We know about this. JavaScript is very lenient when it comes to function signatures, and TypeScript gives us a way to take advantage of that flexibility while still maintaining type safety. Function overloads. First, we define a function that can be called in multiple ways. Yeah. Okay, function employees. It takes in employee is new of type employee. It's new. Optional boolean. Onboard optional date, and then returns what? Okay, it returns a string, and the employees of type. That's okay. Used as is, this function can be called in 3 ways. Format employee message. Okay, we need can be called in 3 ways: 1 parameter, 2 parameters, and 3 parameters. Yes, because these 2 are optional. Okay, but we can constrain the function to only allow a certain combination of parameters by using function overloads. The function overloads needs to be declared above the implementation. Okay, but we can constrain the function to only allow certain combinations of parameters by using function overloads. Function overloads needs to be declared above the implementation. Okay, it's taking something of type employee, and then just this. Okay, let's see. Now it's impossible to call the without also passing in the date. Basically, we're saying if the employee is new, we must also pass in a date. This works. Okay, you see, const employee of employee type. Okay, we saw it employee as the name, and let's see, to the name and date. Okay, and then message format employee, we can pass in this. Yeah, and then it prints. Then if we have this, we can pass in the boolean and the date employee. Yeah. But if we pass in employee and this only, it will not allow us to do this. Okay, yeah, this is very useful. Okay, Consider the function to allow certain combinations of parameters by using function overloads. Okay. To only allow certain combination. It will only allow either when you pass in everything or when you just pass in the employee object. So the one where you pass in two things, like here will no longer work. The first and the third one now works. We've overloaded it to allow passing one employee. That means it can either be the employee object or everything, even the optional. But no, these are not optional now. Okay, they do not need to be optional here. Okay, they do not need to be optional. Okay, we're just overloading to only allow it this way. Okay, we can overload it again to allow two, and it would work for two, but other than that, it needs everything. Okay, assignment. I think we're done. Great. Preference can be configured in one of two ways: by specifying and the code and says fix the compile time by updating the incorrect order signature. Let's go and try to fix the code. Okay, there's a function, export function. It's just taking in two things. Camel preference. It can take another thing. Yeah. Okay. So here we are. Okay, we're trying to over. Yeah, if we're gonna overload, we don't. Okay, yeah, we don't overload this to allow it to run when you're passing this. Do not disturb it out of this. You see? Okay. Okay, so we want to override it, do this. Okay. This wasn't. Okay, it will be required, but we want to allow it to the same. This overlay signature is not compatible with implementation signature. The implementation is declared here. There's not nothing. Okay. You. Okay, if type of is a string, then we'll return this one. Else if, then we'll return this one. Else if. Okay. Don't touch code below this line. Okay, I touched code below this line. Let's see. Let's fix this. Okay, what do we do? I don't know what to do, really. Okay. Can we remove this so that it's the return type so that it's inferred? No. We need to do something. What do we need to do? Yeah, we're trying to override it, right? Now it's possible to call. So this is incorrect. Why? Okay, it's okay. Boolean. Oh, it's expecting a Boolean number. So let's expect a Boolean string. Yo, I spent like an hour trying to figure that out. Like I was checking if it was Boolean what. It's Boolean string. So it shouldn't be Boolean or number. It should still be Boolean string. So we're going to go ahead and again, then try to run. You do not need to check anything sometimes. Sometimes all you need is patience, and eventually you will be able to fix the bug. Yo, I was trying to look for a case to pass input boolean blah. We solved the thing. It's gonna expect at least two things, so we can pass true, and it will be to work. That we passed on do not disturb, and let me just check if we did not pass the object. Yeah, we passed in do not disturb and out of office, and then it will do not disturb true. Yeah, it will return an object of that. Yeah, it will return this. So like that will be today. That will be today. That will be the end of today's video. Next I'll do tuples, and I'm gonna have to rest it and study. So I will see you guys on the next video, hopefully.